I'd like to introduce a question of Ontario, Canada, grade 12, physics for university preparation, coded as SPH4U. This is the question. Coil spins to throw a rock. The rock's weight, rope's length, velocity, angle, and the height of the rock, the tension in the rope when he let the rock go, are all known. The question asks the distance between the points where the rock is let go and where it hits the ground. This is figure 1. O is the point where the rock is let go. Line OH is horizontal. The angle between velocity v and OH is 30 degrees. The angle between the rope tension T and the horizontal line OH is alpha. The rock's weight is G. G is 2G newtons. G is acceleration of gravity. The rock weight G, the upper letter G, and the rope tension T together form the centripetal force F. So F is the resultant of G, this force G, and this tension force T. F is the resultant of force G and force T. This is the legend of figure 1. Since force F is the centripetal force when the rock is let go, force F is perpendicular to velocity v. So the angle between force F and horizontal line OH equals 90 degrees minus 30 degrees. That's 60 degrees. Force F, the angle between force F and the line OH is 60 degrees. The centripetal force F is the resultant of all the forces exerting to the rock. Forces G and T are the only forces exerting to the rock. So their resultant is force F. And the sum of horizontal components of forces G and T equals to force F's horizontal component. And the sum of vertical components of forces G and T equals to force F's vertical component. So we get this equation system. We get this equation system from what I just now said. This is what I just talked. From this equation system and these triangle formulas, we can solve the force F. Here's the calculation. From this formula, we can calculate the velocity v when the rock is released. This is the velocity v of the rock when the rock is released. This expression is derived from this formula. This is figure 2. This parabola is the rock's projectile track. A is the point where the rock is let go. O is point A's horizontal projection on the ground. P is the parabola vertex. Q is the intersection of horizontal line AQ and the parabola curve. R is where the rock hit the ground. D is the distance of points O and R. V is the rock velocity when being let go. VV and VH are its vertical and horizontal components, respectively. The angle between the rock velocity V and the horizontal line H, horizontal line AQ is 30 degrees. The distance between P and the line AQ is small h. The length OA is 2.15 meters, as told in the question description. This is the legend of figure 2. A Chinese celebrity once said that though home life was long, the key was only a few steps. I would like to talk about these steps for this question here. There are two components in projectile motion. One is the horizontal uniform motion. The other one is the vertical motion with gravity acceleration. This question asks the distance of points A and R. After we get the horizontal component of velocity v, that is vh, what we need is the rock flying time in air after being released to calculate the distance. I mean the distance between points A and R. Since we know the vertical distance of points A and R, the vertical distance of point A and R equals to the length of line OA. And component VV we can also calculate. We can calculate the time for the rock to move from point A to point R using the vertical component of the projectile motion. Here we get the vertical component of velocity v, that is VV. We can use this expression to calculate VV component of velocity v. Considering the vertical component of the projectile motion from the start point A to vertex P, from A to P, we have this expression, and we can get T1. T1 is the time for the rock to fly from point A to P. I mean, from the start point A to the parabola vertex P. Again, considering the vertical component of the motion from point Q to R, from point Q to R, we have this equation. From point Q to R, we have this equation. And we can get T2 from this equation. We get T2. So T2, what's T2? T2 is the time for the rock to fly from point Q to R. Here, T2 is the time for the rock to move from here, point Q, to here, point R. This is T2. Then we can get the total time when the rock flies along the whole projectile track from the start point A to the end point R. So this is the total time for the rock to move from the start point to the end point. From here, the start point, along this parabola curve to the end point R. The total time is formed by 3 parts. From here to here, from point A to point P, the time is T1. From P to Q, the time is equal to the time for the rock to move from A to P. So there is two to 1. From here, from A to point Q, we need 2 T1 for the rock to travel. From point Q to point R, we need a time T2. So the total time TT is 2 times T1 plus T2. Tt equals 2 times T1 plus T2. So we can get the total time. With this total time and the horizontal component of velocity v, we get the distance d. What's the distance d? This is the distance d. The distance between points O and R. That's the horizontal projection of points A and R. I mean, the distance between points A, the horizontal projection of line AR is OR. So this is the distance D. D is the horizontal projection of AR. So just now we get the value of D, and we also know the length of line OH, and OAR is a right-angled triangle. So we can calculate the length of line AR. I mean that the distance between points A and R. That's what we need to calculate. So we can calculate the distance between A and R. This is the result. In the calculation above, we have considered the effect of the rock's weight on the centripetal force F. If we ignore the effect, we can get this result. So this is the result without considering the weight effect on the centripetal force F. To read the scripts of this video, please visit my blogs, whose web address was listed in this video's description below. Welcome to comment and press the subscribe button at the bottom right of the video. Thank you very much. Bye for now.